Hello everyone, welcome to my channel. This video is mainly for short notes and chapter is solid state. In this video, I will mainly tell you 5 points of solid state. If you know these 5 points or if you remember these 5 points, I think you can solve out the problem in CSIR NET and GATE. And this video will be helpful for you also. This video is only for short notes. In my previous video you can get the description of the points which I will tell you. First thing, for solid state, at first or for crystallography, at first you have to know how to calculate the number of atom in an unit cell, that is the sharing of atom which is in edge center, which is in face center, which is in corner position, or which is in body center position. If you know the sharing, you can easily calculate the number of atom in an unit cell. Second thing is the packing fraction. Some problem which are coming in generally, which are coming in CSIR NET or GATE, which are related to the packing fraction. And if you remember the packing fraction of some simple system like simple cubic, FCC, BCC, you can easily calculate those problem because and you don't need to calculate the packing fraction in exam center if you remember. First is the packing fraction of simple cubic, which is 52%. Packing fraction of BCC is 68%, and packing fraction of FCC, which is 74%, FCC or HCP. And another important is packing fraction of diamond crystal, which is 34%. If you remember this value, only these 3-4 values, you need not to calculate it in exam center. Third is the density, that is the equation for density. There is some problem which is related to the density of the crystal, and if you know the formula of the density, just by putting it in the formula you can easily solve out that problem. And for that you have to know what is the formula of the density. The formula of density is Nm divided by N into V, where N is the number of atom in an unit cell. At first I told you that you have to know what is the number of atom, how to calculate the number of atom in an unit cell. The first thing is that for density, where N is the number of atom in that unit cell, M is the atomic mass of that respective atom, or if it is like salt or anything, then molecular weight, divided by N, where N is Avogadro number and V is the volume of the unit cell. And generally problem comes in the problem there are cubic unit cell, that's why V is equal to a cube, where A is the edge length of the cube. And you have to know the relation between the radius of the atom and the edge length of that unit cell. Relation between radius of the atom and the edge length of the unit cell. Like in some problem there are radius is given, not edge length is given. Radius is given and the density is given. You have to calculate M or what is the species involved. Then for the calculating the value of V, you have to know what is the value of the edge length of the cube. If the radius is known, then if you know the relation between the radius of the atom and the edge length, then you easily can calculate the volume of the unit cell. So density, the relation of density is very important thing, and you have to know you have to remember the formula, that is rho is equal to n into m divided by n into v. Fourth thing is that the Bragg's law, that is 2d sine theta is equal to n lambda, where d is the interplanar distance, theta is the glancing angle, n is the order of reflection, and lambda is the wavelength of the X-ray source used. That is, there may be some problem where you have to calculate the value of d and theta and lambda is given. There may be some problem like this, then you have to know the relation between d, theta and lambda, that is, which is Bragg's equation, that is 2d sine theta is equal to n lambda. And the last one is the very important, that is the relation between the interplanar distance and the Miller indices and the lattice parameter, where ABC is the lattice parameter. Here the relation is the 1 by d square is equal to h square by a square plus k square by b square plus l square by c square, where ABC is the lattice parameter, HKL is the Miller indices of the plane, and d is the interplanar distance. This relation is very important, and this is applicable for all type of unit cell, and for cubic unit cell the d, as a is equal to b is equal to c, then d is equal to a by root over of h square plus k square plus l square. And this is very important relation in solid state. You have to remember it to solve out the problem. I think this video is helpful for you for short note preparation. And if you have any suggestion, please comment on it. And thank you for watching. If you like my videos, please subscribe my channel and like the video and share the video. Thank you.